my area.
Your model assumes that technology is superior. It is not.
Oh, no.
Humans are superior.
By far.
So all they're doing is infecting human psychology using technology. Technology is not the solution.
And an algorithm can only ever approximate a human-capable decision. It will never actually beat one. And simply throwing more examples at it is not going to make it intelligent either. What makes a human being, even those among who consider less intelligent, is adaptability and creativity. And that's what we keep engineering out of our systems. So I'm saying allow the algorithm to be adaptable and actually generate things that you don't say, well, that's wrong because I couldn't validate it, but say, it's plausible. It came out of the model you learned, and this is its opinion as to what can happen. And then if that's an opinion, build a classifier to prepare for that in the event it should happen, instead of saying, well, that's not what I expected, so we're going to call that your algorithm didn't work. I say, no. Run through it and then get mitigation courses of action ready for what the algorithm says it thinks can happen. Yes?
In terms of the technology and the science, yeah, it seems like you've been working on it for a while. So
Yeah.
I really find it difficult to believe that there's no commercialization that is successful. Whether it's Boston Dynamics that use proprietary or like top secret or DoD dealing with this. So can I get just examples that I can just look at? Like for example, if you think about big data and the change in like how operations and implementation of backend services happened for the past 10 years, there's an evidence that the science was there, the distributed system were there, but then the execution and the commercialization and how the system grew in the past 10 years just blasted out.
Well,
Right. Is this just a white paper, or is somebody doing this?
Like, I can't believe that
neither.
Boston
I
Dynamics is not even
have
using
done
it.
all of this and published results on it, have done SBIRs and shown pieces of it, and have believed at one point I had my own business that I was going to be bought out and become $100 million, and I got ignored, and now I'm an employee of one of the companies, and have brought all of this to them, and they decided to take 1/10 of 1% of it and put it in there and think how great that is. Look, it's different, and we're not used to thinking in these spaces, and everybody wants a novel solution, but when we hand it to them, they go, that doesn't look like what I expected it to look like. Well, what am I supposed to say to them?
A lot of this is sometimes companies can't figure out how to commercialize it.
Yes?
So there's a company called Hadoop, right, where Yahoo developed
Maybe that's the way
Hadoop,
you
right?
do it.
They didn't know what to do with it, and they open sourced it.
I mean,
But
a lot
it's
of
been out
this
there.
stuff that
Right,
even with source codes.
was actually, some of this stuff was back in the 80s
Okay.
that was being done. So,
This is also open access. You can find it in the IP. There is no IP.
My stuff has been out for years. My charts, 1998.
That's great.
You may learn.
All right, I'm going to prove how easy it is to get started with Splunk. Go to Splunk.com if you've got a computer. Click on, when it comes back, it'll say cloud trial or free cloud or something. Click on that, and the first person you get, the first 2 people that get signed up, it doesn't take a credit card, but it does take an email. I've got 2 freebies here, right there, Splunk Cloud. Click on that. It should take you less than 2 or 3 minutes while I'm getting started up. So I'm going to bore you with who I am, but first 2 guys say, I'm in, and I got a goodie for you. Go for it.
Okay. Ladies and gentlemen, we've got Greg Woodcock. He's an independent consultant, currently a Splunk specialist. Some of his clients include T-Mobile, Silver Holdings, Global Metrics, and Nortel Software Development. Holds a Bachelor in Science from the University of Illinois. 4-year rest, very impressive. Excellent. He's an 11-year Awana leader of Arapahoe Road Baptist Church here in our local area. 2-year hobby beekeeper. You're full of surprises.
Yeah, that's right. Actually, those got washed away in the flood.
Well, I'll leave you in his capable hands.
All right, we got new batteries, so hopefully the sound will be better. All right, make sure you yell when you get in. I'm going to be quick. I don't know if I can be quick as he was. He was great, but I don't have much time. So Deb, keep me straight on time. Give me the wave when we're up. I'm just going to go as far as I can. Splunk is a time-based, plain text, big data engine and platform. So anything you can put into plain text either by converting it or by telling Splunk how to convert it. You can send to Splunk, and then it does, instead of taking a Hadoop route where you need an engineer to create your MapReduce job, it provides you with a very powerful and very learnable, in bits and pieces, command set called SPL, the Splunk Programming Language, and that allows you to create sort of shell-ish, script-ish search commands that then Splunk converts into the MapReduce job and sends it out to your distributed index space and pulls the answers back to you. So I'm going to show you how quickly you can go from just having some data and seeing something that you can do using the Splunk Cloud. Somebody should already be into Splunk Cloud if they're doing that. Anyway, you should end up here, click Free Cloud Trial, then you end up here, click this thing, you go down here, continue, it'll make you create an account and you're in. So I'm going to be using the Splunk Cloud Trial. When you get in, it'll look like this, and I'm going to show you just basic how to explore your data, how to get some knowledge out of your data, and then how to visualize your data and create an alert, and that'll probably be all the time we have. But whereas these first two presentations, which were good, particularly the last one was just great, this is one where you can really sink your teeth into because you actually go home and do this yourself. So this landing page right here, one of the things I'd like you to get excited about is you don't need a Tableau license. You can use Splunk Cloud to be sort of like a 75% Tableau. It doesn't have all the great visualizations that Tableau does, but Tableau has way more than anybody really needs. So anything you really need, you can do with free Splunk Cloud. Yes? You're in. All right. Both y'all are in? Okay, here's the freebie. One's a t-shirt and one's a koozie. Y'all split it. Okay. So when you get in, you're going to land right here. And what you can do is, like I said, this is kind of like a free Tableau. You can take your CSV file, save your spreadsheet or your raw data set as a CSV, and you can just drop it right here. It will ingest the data in the cloud, and then you can start playing with it. I'm not going to do that because I'm going to use the data that's already in there. So when you log in, you can write down this one search string, and then you can start playing with the data that's in there. But what you would normally do to experiment with, like say you have some router data that you exported off your router. Like you used to tell young people, they'd say, how do I get started and make $1 million in tech? And I would say, well, go download the Android dev kit and build something stupid and then build something cool once you know what you're doing. Now I tell people, go sign up for a free Splunk Cloud, get a data set that's interesting, like off your router or whatever, throw it in and learn how to use Splunk, and then go do something cool with Splunk, because they have all these hackathons and all, like governments now and medical universities are starting to have these, like, let me see what you can do with our big data set. So they'll go out, like, one of the cities had all of their transportation data, like here's everything with all our buses and trains and stuff. Show us what you can do with this data set. And you guys can use Splunk to do that. It's really great for that. So anyway, we're going to look at, this is where, anytime you're in Splunk and you click on this corner right here, this Splunk thing, it'll take you back to where you would be when you log in. We're actually going to we're going to skip that. It's going to draw here in a second. We're going to click on search and reporting, but it'll take you here. So everything in Splunk is in an index. Splunk categorizes things 4 ways. Every event has to have a timestamp. You have to tell it that the data lives inside an index, which is your physical space where you put it. You have to classify it with a source type, and then Splunk will assign it a source. For example, if it came from a file, the source will be the file name. If it came from a port, the source will be a server at port. If it came from other stuff, like a Windows event, it'll say it came from this server and it's a Windows event, a Windows security event or whatever. So depending on what it is, it will give it a source. You assign it a source type. You choose what this thing's going to be called because you're creating the taxonomy for your data set. And then you also tell it where to put it. Where to put it is indexed. So in Splunk Cloud, the underscore, in Splunk everything, underscore whatever is what Splunk uses internally. And the reason that's important is because they don't charge you license on anything that's in underscore. So that's how it talks about itself. But there's underscore internal, underscore audit, underscore introspect. So any Splunk index is automatically going to have data in underscore whatever. So that's what we're going to look at. We logged in our Splunk Cloud. We went to Search App. We just clicked on this right here, searching and recording. It took us to this screen. And I typed index equals underscore scar, and I picked last 24 hours, right? Just basic data set. I don't know what's here. Let's take a look at it. So what it'll do is anything that's interesting in here, that it automatically extracts out key value pairs. So like this says output Q depth equals 0. Well, there's going to be a field name called output Q depth. Should be. That's weird. Why is it not pulling that? Well, there's other stuff. It doesn't matter. Like I said, I'm looking at what's here. I'm exploring it in real time here. We'll take a look at something that we can see. One of the things that Splunk does to help you classify your data is it pulls out of your raw data, it pulls out all of the alphanumerics and just keeps the punctuation, and it creates a field called punced. So we can look at punced and we can say, for example, if you have syslog, it looks a certain way. Certain applications will generate their logs in a fairly standard punctuation format. So this is a way for you can say, without knowing anything about your data set, what stuff looks together, what's the most stuff that's in here. And it's a really good way to find your outliers. Like this, I've got only 1% of these. This is your outlier data, almost certainly. Another thing Splunk provides is whenever you run any search, there's an event tab, a pattern tab, a statistics tab, a visualization tab. When you run a search like this, index equals star, it will take you to the events tab, where I said you can go to pumped. You can look at this pumped field, and you can just click on it. Like let's look at this outliers, and you click on it. It adds that to your search. The field pumped equals this value, and you can say, okay, here, and then you can go up here and say, well, what index is that in? Okay, that's in internal. What host? Well, there's only one host because I'm in the cloud, so I have one instance of it. What source is it? This is coming from the metrics log. So this is a Splunk metric. Obviously, Splunk metric of this format doesn't get generated that much, but I'm already able to drill into and see something about what's in my data really quickly, like without knowing anything about it. I deliberately did not look very much into this because I want to show you, I don't know about this because they used to have fake data when you signed up for Splunk Cloud. It had like a fake store, and they turned that off for some reason. So I don't have data to work with. Otherwise, I'd be using that. So we're just going to look through this stuff. The other thing you can do is you can go to the Patterns tab. Patterns tab, it says, this is making it the most stupid as to how similar data is when you go to larger. So it says, try and find a representative event that sort of looks like all the other events that look like it, and show me the most common one that you found out of that as that. So this is saying, in all of the data set for the last 24 hours for index equals underscore anything, it says 20% of the events look roughly like this, and this is the most common instance of that in this grouping. And I can actually click on this, and it'll show me all of those events. Now, if I want to make it a little more particular, I can go down to smaller. I just drag this slider over. It's how aggressive or how stupid it is in determining what is like other stuff. So this classified it a little better. If I was to click on this, they would all be of this same punctuation and the same event type. But you see I've got 44 patterns as opposed to 6. So if you want to just explore your data once you pump it in, it's a really good way to say, okay, let's go ahead and take a look at, and let's look at the outliers again. I caused it to be aggressive. Let's look at way low percentage outliers. Here's your biggest outlier category. It's only 0.5%. And view events. So this is what it used to classify that. So now I'm looking at those events. So we're going to move on. This is not the search to write down. There's a search I'm going to show you to write down where you go home and you're in Splunk Cloud and play with this search because it allows all the tabs to be active so you can play with it. This is just showing that I can pipe my data set into a statistical command and it will now land me on the statistics tab. And the command I gave it is go into all the underscore index buckets, pull the data out, count by source type and index, and show me for the last 24 hours. Remember, I have this time picker. You can do real time. You can do relative, like from this time to that time. I'm just using the last 24 hours because it gives me a nice big data set of stuff. and it says, okay, now I can actually see that inside there's underscore audit index, underscore internal, underscore introspection. You can sort by these. Okay, you can sort. You know, if you click on anything, it'll do an alphanumeric sort on it. So what you see here is I've got about 20 classifications of data, and I was able to take. Again, the point is, and it came back pretty quickly, 24 hours worth of data with 24,000 events. It's just like 1 second. This scales really well. In the cloud it won't, because you're in free cloud, you're locked down to one pretty not powerful VM instance. But it's great if you've got like a CSV and you want to do all of this kind of stuff. Splunk is gearing itself to be the single pane of glass for the operations center. So you get not just data ingestion and statistical, the command set to explore your data, but you also get a whole bunch of visualizations, just like with Tableau that we're going to move on to next. So you, instead of piping it to stats, you can pipe it to time chart. You can say count over buckets, spans of 5 minutes, the source type in an unlimited sense. So normally it'll limit it to just 10, and then it'll create, or 9, and it'll create a thing called other, which I don't like. I want to see them all. So I told it limit. I can do limit equals 3, but if I do limit equals 0, that means unlimited. So if I run this, not for all time, that would be silly. But if I run this again for the last 24 hours, what's going to generate, again, is statistical data, tabular data, what would normally be spreadsheet kind of data. But now I can also click on the visualization, and I can start visualizing this data. Okay, so you see that this data has very good periodicity with some instances of outlier effect going here. But what I notice here is that, you know, because they're not, like we said, they're not in the same index, so they're totally different kinds of data. What happens a lot of times when you do that is you'll have one piece of data like this or like this that sort of ruins your scale. I can't see what's going on with, for example, where's one that's like this one, Splunk Web Access. I can't see really what's going on with it because it's dwarfed by the variance of these other ones. So, but that's okay. I can just go in here and reformat the way it does line graphs. I can go in here and say, for the y-axis, make it logarithmic instead of linear. Let me see what that looks like. Oh, that's much better. Now I can sort of see the variation. Here, I say, you know what? I don't really like this. I want to see, you know, an area chart, you know, or whatever. You know, go in here and do it. Now I've got them overlaid on each other, so I can see that the volume of this one, you can see through each other. They're stacked on top of each other as an area chart. So I can see that, you know, compared to everything else, the guy that has the most events is Splunk D, right? He's always higher than everybody else. And I can hover over these other things and see how they compare overlaid with each other. Or maybe you want to, you know, you can do any of these visualizations. Once you have a pie chart, and say, you know, let me just see in a pie chart, you know, how they relate to each other. Just change your visualization. You don't like your colors, you don't like, you know, any of the parameters, you just go in there. Once you select the visualization, you go in there and you just change whatever the parameters are that are generally associated with that kind of thing. You want a multi-series thing where you spread it out where each one has its own graph. Now I got too many things for that, but when I did that, what it did was it said each one has his own graph space stacked on top of each other. So it iterated it, which I have too much data in here. It doesn't visualize well. But my point in doing that is just to show you how quickly you can move from thing to thing to thing. You can say, well, how do you treat blank spaces? You know, null values. If I have a time slot that has no events, what do? Do I bridge over? Do I drop to 0? Do I leave a gap? You know, you can tell it. Oh, in this case, it's kind of hard to see what the values are. They really should do their shading a little better. But you can tell it dropped to 0 where there's nothing. You know, it'll change your graph. In this case, this is continuous stuff, system stuff. So there's always something in 5 minutes. So that doesn't really, well, maybe there's a drop right there, or there's a place where that would have normally gone straight over, but it dropped to 0 because there was data there.
Can you do a heat map?
You can do a heat map, but it's a little more complicated than this because you have to instrument it into the search. I don't have the time. Normally I have an hour to 2 hours, and I make it very interactive. You stop at any time, you ask your questions, but you can do a heat map. It actually happens on the stats page. Where these are changing, and you have to turn it into a real-time search, which slows everything way down, but you can do it. It's a common use case, but the cloud with one what the constraining to is not really built for real time. As soon as I go real time, it's going to slow me down, and it's not really going to work. But if you're going to do real time in Splunk, Splunk, it will consume one core on every piece. One core on your search head, one core on each indexers to do real time, and things will slow way down. You have to scale your Splunk instance for real time if that's what you're going to do, or it's just not going to work. So I want to show you also, we're going to take this visualization that we just did, and I'm going to say, okay, like this thing normally varies between 600 to 700 is the variance. There's a spike here. Let's say that we don't like that spike. We say normal because we're humans and we can see normal is like 600-ish. 650 is, it never goes above there unless there's something weird going on. Let's turn that into an alert. Let's first of all click on just this source type because we're going to say we're going to track that. So now we just have Splunk 2. And I want to go back to that time chart. Span equals 5 minutes. Let's count. Chart count. Go back to the same visualization. It took me to the raw data set. It stripped out the visualization part. So now I just have Splunk D. And also, it copied the time range. When I ran the search, it was 24 hours, but it was 5 minutes after that. So when I drilled into it, it said, oh, 24 hours ago, but 5 minutes ago. That's why it changed to the date time range. Just make it back to 24 hours, just to make it easy for us to track with it. Okay, so here it is, and I want to save this as a dashboard because I want to track this. It's as simple as clicking Save as Dashboard Panel, and I have to give it a dashboard, and then a place for it to go, and then a panel in that dashboard. So we're just going to say Sample Dashboard, and then we're going to click Save, and then it's going to say go view that dashboard. Now I have a dashboard called Sample Dashboard, and I have a panel in this dashboard. I can edit this as XML, edit this source. I can go in and grab, say I like this, but I'm going to iterate over it a bunch. I can grab from row to row. I can do a copy and a paste, and then I can save the XML, and I've got the panel now duplicated, right? And then I can do edit the panel. And so I can go down here and I can do the same thing, these same controls that you had on that. I can say, you know what, I want to call this Splunk D pie chart. And then I'm going to go over here and I'm going to change my visualization to, oh, that's stupid, Splunk D pie chart. There's only one source there. That's really dumb. So I'm going to actually edit my search string. And I'm going to make it, instead of source type equals Splunk D, I'm just going to get rid of that. I'm going to go back to what I had before. Now I've got a visualization, it's a pie chart, so it's really easy to, and I can drag this, you want to say, well, let me make these side by side. I just drag it up here next to it, and I drop it. Sorry, my mouse is kind of, my trackpad is kind of dead on this thing. Now I've got them side by side. It's easy. Now I'm going to say, okay, you know what, I got that done, but I still am interested in this spike. I want to turn that into an alert. So I'm going to drill into this again, and it's going to take me back to a search with that data set. And I'm going to do save as this time as an alert. And I'm going to give the alert parameters. I'm going to say if it's ever above 600, send me an email. Well, it is above 600. So it's going to start sending me emails. I've got my Gmail right here. I'll teach you guys a cool Gmail trick for spam too that you might not know. So I'm going to go ahead and save this as an alert. And I'm going to say send me alert every minute. You would never do something stupid like this. But this is for demo only. And so I'm going to schedule this by cron. You guys are geeks, right? And I'm going to say I'm going to run this thing every star, that's every minute. I'm going to run it every minute, and if the number of results is greater than, what it means, not the number of results, we want to see the value, is greater than. Oh, well, it's 2. Yeah, it's greater than 600. We know it is because they were all. Then we're going to send me an email once for each result. We're not going to throttle it. You can say, hey, once this triggers, don't trigger it again for an hour because you're not going to say, well, you get one of these every single minute. You're killing me. Like every time I down the alarm, it comes back. You can throttle that stuff. This can generate SNMP traps right to your knob. Like I said, they're trying to be a single pane of glass. And I'm going to have it send me an email. Send email. And here's the email trick I was going to tell you. If you have a Gmail, you can do something like this. Anything after the plus, if you do your username plus anything, is automatically an alias to your email account. And then in your Splunk, you can filter and say, for example, if you sign up for Splunk Cloud, you make it your user ID plus Splunk Cloud, then you know Splunk Cloud's the one sending your stuff everywhere. And you can put a filter and say everything that comes from there is sent to trash, and then receive again. Right? So you get free infinite aliases with Gmail. Many people don't know that. So that's a bonus tip there. And you can give it a priority. This priority shows up in inside Splunk's alert system, so not just an email, I'll get an alert. So I go ahead and save this, and that's fine. Now this is going to start alerting every minute I'm getting an alert, because every minute it has data, and it does work automatically from the cloud to Gmail. So you can actually take us to your Splunk Cloud demo. You can put a forwarder on a system, any system. It uses a token. Anything that can HTTP post, you can send data into your Splunk Cloud instance. So you can say, here's your token, build it in the forwarder. I need a forwarder for Linux, or we're stopping. And you can start forwarding data from whatever, and you can actually exploit it. Or you can drop a file in, and you can do all of these visualizations in your file right there. So it's sort of like a free Tableau. Now, my time's up, and I'm really sorry I didn't get to tell you more about that. Like I said, it took like 1 or 2 hours and 15 minutes. But Deb can get my information. I left some free Splunk sheets down there, and so I didn't bring my cards. I was in a rush this morning. So there's some health checks. But you can find me in Meetup. You can find me through Dev. And Splunk is really easy to learn, and it's big space. It's hot. All right. That's it. I've got a question, though. What's up?
Yeah. How it is different from Apache Solar indexing or searching?
So they
comparative studies.
Yeah. So I mainly focus on Splunk. So I don't have very much experience in other stuff. I know that with Hadoop, Splunk, because Splunk, Hadoop they were sort of the two main things. There's a bunch more now. But generally, if you go high enough volume, high enough raw events, Hadoop will start to win. But we're talking about in petabytes per day of data. So under that, Splunk generally wins right now on their reference hardware. But the higher you go, the more Hadoop's eventually going to be faster. But you still have that, you need a person to write your MapReduce with Hadoop, which you don't need. Now the other cool thing about Splunk and Hadoop is Splunk has a product called Hunk, and Hunk allows you to treat your Hadoop infrastructure as faux indexers. So you can actually buy Splunk, buy Hunk, point it at your Hadoop data set, and you can use the Splunk command set to write your MapReduce, which is really, really slick. So if somebody said, we've got this big Hadoop thing, and we lost our guy that writes all our stuff, the first thing I do is say, well, because I don't know anything better, let's just use Splunk by Hunk and do that. Now they also they're about ready to release in the next release the other piece, which is you can write MapReduce jobs in Hadoop and point them at your Splunk indexers, and you can pull back your data that way. That will be coming out soon. So there is sort of this two-way traffic that you can do, where you can do your own experiments for your particular situation to see what works better.
Okay, thank you.
Thank you, Greg.
Thank you
very much.
Thank you.
Greg. Yeah. Ladies and gentlemen, the next speaker we have is Mukesh Kerala. He's a professional BI and analytics consultant with about 20 plus years of experience in IT, specializing in telecom, finance, insurance, and aerospace and defense industries. Currently on a consultant contract employment with Bell Helicopter. With him as well is Chase Giles. He is an analyst at Bell. I'll leave you to your court.
Oh,
Thank you, Mukesh.
All right, my name is Mahesh Chawla. I've been in the data space and software development area for the last 20 years, and been working with helicopter with the business intelligence area mainly, and with everything from SAP BW to business objects, data services, and big data and analytics now. And with me here is Chase Jacks. He's going to start off the presentation and then I'll continue.
Everyone hear me? So I'll just, my part is just going to give you the basic business background on this, because it's really the brains of everything, so I'll step aside once I get my part done. But basically, this project was called Quest, and it's a project focused on a business problem. Focused on our customer service, which we're very proud of. We've been award-winning for the past 20 years.